I'll be talking about global trends on military robotics and autonomous system. I'm the last speaker here on this session, so I have the advantage of referring to the previous speaker. So a lot of things have been already told. Please go to the next slide. So if you do Control L, I think you can do easily next. I mean, that is what I was telling. Okay, so it is anticipated that the warfare is going to be unmanned, indirect, and technology driven. We all agree, I think, here. And there are a couple of books which have been published, very popular books, War of None and the Four Battlegrounds, which actually beautifully defines how the future warfare is going to be, defining these concepts of unmanned and indirect and technology driven warfare. We already see a lot of robots and drones in the war zone. They are already there. Autonomous weapon systems, almost all major forces now they are developing, both lethal and non-lethal. So if you look at the global picture, the military robotics and autonomous system, they are being used in different war zones to enhance the operational capabilities, reduce human cognitive load and fatigue, to reduce risk to injury by increasing the standoff distance, to improve the situational awareness, and in general to improve or enable efficacy, velocity, and the scalability. So that is the overall aim of this military robotics and autonomous system. Next slide. Just for understanding, we can categorize these systems in different ways. We can, based on the platform types, you can have aerial, ground, water, you can have single agent, multi agent, you can have swarm. So all kind of configurations are possible. You can define based on autonomy, level of autonomy. So as we all know, level 1 to level 5 is generally what has been already defined. So everybody tries to, aspire to create systems which are at level 5, which is basically you are defining some mission, and then the system is able to autonomously complete that mission without any human intervention. Of course, right now if you see the autonomous, the driving system, they are at level 2, level 3. So everybody is trying to reach there to level 5. Based on operations, we can have 4 broad category of operations. So ISR, we all know that most of these unmanned systems, they all started for this particular purpose. Then people have nowadays started using for the logistic support. So the aerial platform, the ground platform, they can be used for the logistic support. We have systems with the guns and all for the combat support, and the systems for the combat engineering tasks in order to clear the debris, in order to for disaster management and other activities. So these are the 4 broad categories of operation. Yeah, next slide. If you look at the global picture, there are some focus areas where people have been working. So autonomous weapon system is one where people are working on weaponized drones and loitering munitions, unmanned ground, air, and sea vehicles or sea surface vehicle, man-unmanned teaming. Everybody talked about here about that man-unmanned teaming. So US Air Force has a big program on collaborative combat aircraft program. Apart from that, there are a lot of challenges which people are trying to address. So when in any mission, if there are 2 humans, they talk to each other in certain ways. If they have to communicate to the machines, there has to be some common language in which both can understand. So the human understand languages in certain ways, the machines have to understand in the same language. So when we talk about man-unmanned teaming, those representational aspect, when someone refers to some object like say vehicle or gun or anything in the scene, then the human understand easily. Now the machine have to understand that in the same way. So that representational aspect has to be addressed. The multi-domain operation, that is another area where not only one type of platform, but the platform in multiple environments, they have to work together. So that is another area where people are working. Studies on ethics, social and legal aspect, along with the fixing the responsibility of the autonomous system, that is another area in which the studies are currently ongoing. A lot of work on simulation, because the NVIDIA, I think we saw a good example of simulators. So simulator are going to play a very, very important role if we really want to create autonomous system, because it is not possible to put those systems in the real world and learn there. So, it is always better to learn in the simulation and then apply in the real environment. So, that is one of the challenge that lot of places the work is ongoing. So, if you look at the major power in the world, Major General Mann also mentioned about different countries. So, China, as he mentioned, is going from informatized warfare to intelligentized warfare, where this autonomous system will play a lot of important role. US is working on this third and fourth offset strategies to overcome the challenges which are posed by Russia and China, which basically includes these advanced technologies, areas of robotics, AI and autonomy. In Europe, both EU and UK, they are all working on different programs on these military robotics. Russia is one of their popular program is to create fully robotized unit which will be capable of independent military operations. So, that is something big which they are aiming into. Next slide. So, these are some of the examples. We can quickly just go to the next slide. Yeah, next slide. So in US, if you see, there are multiple players which are like so they have the national labs like ARL, NRL, AFRL, who are working on low TRL problems. Then there are DARPA, which is basically addressing futuristic technology through industry, and they have the large, very large industrial base which are working on these problems. So this slide just captures one, I mean ARL, because we have worked with ARL. So it captures kind of their strategy, how they are looking into deploying these systems in the field in the next 10 to 15 years. Yeah, next slide. So this is the same thing showing in the timeline. I have very little time, so I'll skip that. Next. Yeah. So this is one of the popular program by EU. Already one version has been completed. It is called as Integrated Modular Unmanned Ground System, where they have in last 3 years they have demonstrated various capabilities in terms of man-unmanned teaming, swarming, heterogeneous technologies, cyber defense, and in December 2023 this program has been completed. Next slide, please. So now they have gone to the next version of this, which they are trying to complete by 2028, which will be called IMAX 2. So in the previous one, 8 different EU countries participated. Now in this program, 14 different countries will be participating. Yeah, next. Similarly, UK has got a lot of systems already in place. Next slide. Next slide. Yeah. So just few slides on what we have been doing at CARE, which is part of Center for AI and Robotics, part of DRDO. Next slide, please. So in last 20 years, we have been working on this problem of robotics and AI. So initially, if you see around this 20th century, 21st century, we have been working on mainly manipulator arm, where we deployed a couple of systems for the military for the nuclear application, the NPCIL. Then in 2005 onwards, we have been working on mobile robotics, and recently, if you see, we have been working on creating that autonomous tank and autonomous underwater vehicle, and some work on the multi-agent and the swarming kind of application. Next slide. So these are some of the system prototype system which we developed in CARE. So one of them is the autonomous BMP vehicle, which was done along with our sister lab in Chennai. We have also created this autonomous car. So these are all different vehicles which were taken outboard and then converted into drive-by-wire, and then autonomy was imported onto these systems. Yeah, next. We also worked with US Army Research Lab in one of the project where we created this aerial platform, and we also tried to close the loop between perception and autonomy. So as part of this project, we were able to on the edge, we were able to create models and do the detection, 3D reconstruction, target tracking, trail following. So some of these technologies we addressed as part of that project. Yeah, next. So this is one of the example where you can fly the UAV, capture the images, and use the photogrammetry to create the 3D scene of the area, and then do the better situational awareness. Yeah, I think that's all. Thank you.